And that's going to equal square root of 2 over 2, or negative. Now, here's the trick, though. We're in quadrant 4, right? Because sine inverse exists only in quadrants 1 and 4. Now, some of us might put, we know it's pi over 4. To get to the fourth quadrant, that must mean that this is 7 pi over 4. Is that correct? No. If you look at unit circle, it looks correct, right? But to get to quadrant 4, if it's sine inverse, you have to go down. So this would have to be a negative pi over 4 to get that correct on the test. I think it's important that people get bell work questions wrong. It helps you learn this stuff. That's why bell work it's not going to cost you 1,000,000 points. It won't change your grade. You're just going to see it reflected a little bit, and it'll say, you got bell work wrong, so you lose a little bit of points here. But the big thing is get it wrong and learn from it. Yeah.
Arc cosine isn't that inverse?
Arc cosine, it would be inverse, yes. So arc cosine would be the same thing as cosine inverse of square root of 3 over 2 is correct. They mean the same thing. Okay?
And then you just go square root of 2.
Find that value and figure out what angle it is. Yep. All right. In fact, give me a second. I want to put the unit circle up just in case I have to refer to it. I think I already have it up there, but sometimes I forget. All right. Cool beans. Let's go over homework questions. Now remember, if you just did nothing on the backside, you didn't get full points for this homework, but you can complete the backside and get full points by showing me the back. You can take a picture of it, send it to me, and you'll get the full points. That's what I want you to do. I don't want you just to copy down answers. A lot of times if you just copy down answers, I'll give you points and you won't be able to get them back. Because that's not the point of homework. The point of homework is never copying an answer key. Okay, what questions do we have though? Yeah?
Definitely 19 and 20.
Definitely 19 and 20. Let's do 19 together. I'm going to rewrite 19 a little bit, see if you're okay with it. Instead of arc sine, I'm going to put it as sine inverse because they mean the same thing. Mm-hmm. You okay with that? So we're doing number 19. Sine inverse of sine of 3 pi over 4. This is a composition of function. That means you have to do stuff before you can move on. What I'm looking at right now is this inside stuff. I'm going to solve that before I do anything else.
Sine of 3 pi over 4.
So I'm looking for the sine of 3. First of all, what quadrant is 3 over 4 in? If it's one less?
The second.
Second quadrant. Is sine positive or negative in second quadrant if it's all students?
Positive.
It's positive. Okay, so we know it's positive. It's going to be positive root 2 over 2. So all of that I have in red is actually square root of 2 over 2. I'm just going to substitute that in place of this because it's equal to, and now suddenly I have sine inverse of root 2 over 2. And then it's just going to be pi over 4 because we go to our unit circle, we look at quadrant 1 where sine equals square root of 2 over 2. Well, that's going to be at pi over 4. That is our final answer. Composition of functions are you do the inside function first. Whatever you get out of there, you plug into the bigger function. Do the steps make sense?
That makes sense, yeah.
Is that enough for you to try the next one? 20? Kind of same ideas.
Same ideas, yeah.
So find the cosine of 3 pi over 2.
Okay.
Put that in that place, then find the cosine inverse of it. Okay. Yeah, Seabass.
Just a question on the last 4 questions. How are you supposed to, because it asks you to round to the nearest 2 decimal places in radians, so I'm just a bit confused on what that process is too.
That process is plug it in your calculator.
But it gives it out as it's degrees, huh?
What was that?
Oh, shoot.
It is not in degrees, so if I give you arc sine, just remember that if I give you arc sine of something or sine inverse, it's always sine inverse of a value, not an angle. So what's there? So I gave you, 0.5682? That's not an angle. So you don't know if it's radians or degrees.
Well, you know it.
You know it because the directions say make sure your calculator's in radians.
Yeah.
So you have to put your calculator in radians, and you're just going to type in sine inverse of 0.5682.
Oh, all right.
You sure?
Yeah.
Okay. Yeah.
I had a question on 22. Each
Okay.
time I kept, I guess, inputting it into my calculator, just would give me an error.
What kind of calculator are you using?
TI-84.
TI-84. Okay. Now, make sure you're in radians, first of all. And did you try to somehow put secant in?
I put it in cosine inverse.
Okay. Now, remember to put in cosine inverse. So if I have secant inverse of something, let's call it x. I have to change this to 1 over cosine inverse of that negative 1.4138.
That's really good. For some reason, it's still giving me an error.
Let's check it out. I'll see if I can bring up mine. Where do I have mine? Right here. Bringing it up.
Is that TI-84? Or not?
It'll be a TI-84. I can emulate any calculator that from the TI family. All right. So we have. Let's first make sure we're in the right mode. I'll make sure I'm in radian mode. I believe that's what it's said to do. Got it. Second quit. Get out of there. Now we're going to use 1 over. Now be careful that you don't just put cosine in, because you can't take the cosine of 1 point something. It doesn't make sense to your calculator. So I'm going to make sure I hit the second button and the cosine inverse button. Now we're going to type in. Can someone help me out? It's 1.4138. Did someone say it's a negative?
Yeah.
Okay. I don't think I can do that.
You're going to use arrows.
Yeah.
Oh, yeah.
Oh, and a little note to you guys. Hey, this is a good thing. I'm glad I did this. I don't have to write a negative here because it's going to overwrite 1, which will make me write everything again. Do you see this like insert button right here? If I hit second insert, it's actually going to put something in front of it. So now I don't have to rewrite anything. And then I'm going to go ahead and close this. I'm going to hit enter. And hang on. Did I type it in right?
I was doing that last night as well, and it's the exponent of -1 that was the go-to for me. It wouldn't simplify it for me.
So that's not work. Ooh.
That's
So
why I was
usually when you gotta
confused.
write the inside of the parentheses.
Unless
Oh,
it's-
yeah.
Shouldn't it go-
Thank you. Thank you so much. This is 100% wrong.
Yeah, because that was.
Yeah, I didn't. Inverse, do the reciprocal inside. Inverse, do the reciprocal inside. So we have to put cosine inverse of 1 over, and in fact, I should have that negative again.
Yeah, you don't.
-1. I cleared everything. Cool. We'll go back. So we need to do the cosine inverse of 1. I forgot the negative again. I could do this. I just hate typing on this board. So -1 over that 1.1.
Oh,
What's the rest of it?
Oh, it was 4.
it's 4.
4138.
4138.
Take
Yes,
the
sir.
one. Take
No,
the
take
one
the
out.
one
The
out.
first one.
The second. Yeah, there's
Second.
yeah, it's 1
After the one. After the
That
one.
number
The
right
one
there.
before
is-
this
Just
one.
delete the whole thing.
that one right there.
That's
gone.
4.
Yes.
That one's gone?
Yeah, we don't need
Yeah.
that one.
413.
4138. Does that look right?
Yeah.
So I have to do the inverse reciprocal inside.
Okay.
So now I'm going to hit enter, and now we'll be fine. Now we're
I'm
good.
sorry. How do you do the cosine inverse again on the calculator?
So you're going to hit second,
Second
and you're just going to hit the cosine button.
cosine.
You didn't do it right. Let's clear that real quick.
My fault.
Second again.
Second.
There we go. Now hit cosine. There you go.
What? I don't know. Second.
Other questions? Other homework questions?
I couldn't figure that out.
Homework questions going once? Going twice? Yes. 17. So let me rewrite this real quick because I messed that up. That this should be cosine inverse of 1 over x. So that x would go in there, which would be that negative. Okay, and then number 17. 17 says that we have sine inverse of cosine of 2 pi over 3. I'm just going to shoot through this one really quick because it's the same as the other one. You'd find the cosine of 2 pi over 3, which should be a negative 1/2. You'll plug that in for that, so we'll have sine inverse of negative 1/2. Do not put that it's 7 pi over 4. It has to, or I'm sorry, don't put that it's 11 pi over 6. It has to be a negative pi over 6 for your answer. Because it's in the fourth quadrant, we go down, and you can't go all the way around. Yeah.
Can you go back to that last page, if possible?
What's the last
On
page?
The calculator.
Oh, that's on
is
my
that-
home screen.
is that gone? Oh, okay. Sorry.
That's okay.
Can I just take a picture of that?
Yeah, go ahead.
Sorry.
Yeah.
Okay. Sorry.
Good?
Thank you.
All right, yeah. All right, today we're talking about just tangent and cotangent inverses. So let's make sure we put all our computers and stuff away. We probably shouldn't have had them out anyway. I'm okay with that a little bit because you're asking questions. Okay. No, but we'll have to continue. All right, so to graph tangent, if you remember, tangent had vertical asymptotes at negative pi over 2 and pi over 2. And our tangent is always going up like that. Well, remember that tangent actually continues over and over and over again. And that's why it does. I'm going to do this in light because I don't care about this that much, that it would just do this. It would do this. You don't need to write those if you don't want to. Because here's the important part. All of tangent does not pass the horizontal line test. But what if I just took one cycle of it? Would one cycle of it pass the horizontal line test? Yes.
How does it not?
It has to pass the horizontal line test to, yep, for all of them. Has to pass for all of them. So mathematicians are like, let's just do this as easy as possible and just do one cycle. Well, one full cycle of tangent goes from negative pi over 2 to a positive pi over 2. That's from down here to up here. In other words, I want to go from negative pi over 2, go all the way around, I'm going to erase that in just a second, to positive pi over 2. Which means tangent exists, I don't want that to be white, I want that to be black. Tangent exists in quadrants 1 and 4 just like sine. Just like sine, tan inverse exists in these two quadrants. Just like sine, if I get to quadrant 4, you have to use negative angle. So negative pi over 6, negative pi over 4, and finally negative pi over 3. So it works just like sine, except for its tangent. The good thing is tangent should be on your unit circle as well, because I told you that should be something that's memorized and you put down on there. All right, now to tackle the inverse really quick.
Just like, if you just like turn the graph over.
It's basically kind of like you
like
just
the
turn the
same
graph.
thing, right?
Yep.
That's
So
why I was looking at the other ones.
Yeah.
It was like the same.
well, it's what happens when you flip your x and y values. So the tan inverse is going to look something like this. If you plotted some x, y points, I don't feel like taking the time, but it would look like that. That right there is the cotangent inverse of x. But like you said, and like maybe I didn't say it in this class, but other classes, this will always go over y equals x. You don't have to know that. We're not in an inverse section of graphing. We will later when we get to more of the algebra concepts we do. We'll focus on how to graph all inverses. But right now, just remember that when you flip your x and y values, that will just basically, like you said, it basically just turns your graph of sorts. Flips and turns it. Okay, so that's cotangent inverse. But like I said, for the test, make sure you know quadrants 1 and 4 are tangent. Those are our big things. Can we close our computer? I think I asked already. Thank you. Or do you have your unit circle up on there? Oh, okay, I'm sorry. You can absolutely have it open. I completely forgot about that. That's on me. Okay, so we have the same rules. I'm going to ask the same questions. Is tangent on your unit circle?
Yeah.
Yes, it should be. So I don't have to do any reciprocals. If it's on the unit circle, you don't have to do any reciprocals. All you have to do is figure out where tangent equals square root of 3. And you're only looking at quadrants 1 and 2, or 4, 1 and 4. Is there a place where tangent equals a positive square root of 3?
Yeah, pi 3.
Pi over 3. Yeah. Quadrant 1, pi over 3. Cool. Not so hard, right?
Yeah.
Is there a place where tangent equals a positive 1? Where is that at? Pi over 4. Now, I'm going to ask one more question. I'm going to add this. We'll make it a C. What if I asked for tan inverse of negative square root of 3 over 3? Would you be okay if I said that this was 11 pi over 6?
What?
Night.
If I go to 11 pi over 6, would tangent equal negative square root of 3 over 3?
Well, yeah.
Go by my question real quick. If I went to 11 pi over 6, would tangent be negative square root of 3 over 3?
Yes.
Can someone explain to me why my thinking is incorrect here with inverses, though? Yes.
You can't go all the way around. You have to go back negative.
I have to go back down, so that's why this is
You can only do it
incorrect.
in 1 and 4, right?
Yep.
That's why you can't. It's not.
That's why you can't go all the way around, so you has to be that negative pi over 6.
But it's.
You have to start thinking that way. That way you can get it correct. Yeah,
Is
Adrian.
it 2?
There are two,
I
but
wrote. Okay, so this one I just don't care about.
we're only in
Go to
quadrants
this one.
1
So
and
it's just
4.
pi over 6.
Yep.
Negative.
Only 1 and 4. That's why we have to do that, because it can't be,
Okay.
oh, what about 5 pi over 6? Nope. Got to cover that up. That's why we did that, so you didn't have two possible answers. I don't want you guys to have to guess at which one I think is the correct answer. Okay. How is the inverses going?
Pretty all right.
They're okay. It just takes practice.
It just,
Now, you ready for the loop? No. It's just a small loop, and it only happens on cotangent and only specific cotangent ones. Bamsis. Cotangent. Cotangent looks a lot like the tangent graph, except it gets shifted over a little bit. So we're going to have a vertical asymptote at 0. We'll have a vertical asymptote at pi. Tangent is all rise. Cotangent's all fall. It would look like that. Now, once again, for cotangent, I'll do this very lightly because we know that it just keeps repeating over and over and over, but we don't need to show that. My point is, it doesn't pass the horizontal line test. Once again, doesn't one cycle pass the horizontal line? Yes, one cycle passes the horizontal line test. So, what seems like it's going to be just as easy as tangent is they said, well, we'll just do one cycle. We'll do one cycle. That goes from 0 to pi. If on your unit circle you look at 0 to pi, so if I was going 0 to pi, that would be quadrants 1 and 2. That's where cotangent exists. Cotangent inverse. Let's do the graph real quick, and then we'll talk about this super complicated thing that's below it. Yeah. It looks menacing. It isn't. There's an easy way to do it. I always try to find an easy way that if you practice, it makes your life easier. Let's graph the graph. Yeah, that makes sense. All right. So if I have a vertical asymptote at 0, the inverse would have a horizontal asymptote at 0. So we'd have a horizontal asymptote at 0. If I have a vertical asymptote at pi, on the x-axis, I'm going to have a horizontal one at pi going through the y-axis. And then our graph is going to look something like this. Once again, I'm not overly concerned. Nope, I did it the wrong way.
What?
Stop.
Oh, it's on the.
Don't copy it. I did the concavity wrong.
Start
It looks the other way, yep. I was like, something does not look right about that. I corrected it. Hopefully I was far enough ahead that no one had to write that down and erase. If you had to erase, I'm sorry, but I'm pretty sure if that's the worst thing that happens to you today, that you had to erase something, I think you're going to have a pretty good day. All right, guys, here's our problem. Here's our problem. Let's go in our way back machine to yesterday. I saw you yesterday, right? Yeah. Yesterday I said, okay, if I did cosecant inverse. If I did cosecant inverse, we said it's not in the unit circle. So I do the reciprocal. And turn it into sine. That only worked because sine and cosecant shared the same quadrants for the inverses. Cotangent and tangent exist in different quadrants. They both overlap at 1. That's good. Tangent inverse has quadrant 4. Cotangent has quadrant 2. Let's talk about where that's going to be a problem. So let's just do some problems and see what happens. All right. We're still going to ask the same questions. We're going to still do the first step the same. Cotangent, is that on your unit circle?
No.
No, tangent is. Is cotangent on your unit circle? No. Is cotangent on your unit circle? No. Is cotangent on your unit circle? No. Inverse reciprocal inside. We're correct. So I can go ahead and say, oh, you know what? I'm going to turn that into tan inverse. Reciprocal of negative 1 over square root of 3 becomes negative square root of 3 over 1.
That's just negative square root of 3.
Hold that thought for a second. Because you are correct. Ish. You're correct in your assumption. You're incorrect on your solution. I don't want this. I want another fresh unit circle. Where are my unit circles? There you are. Adrian, could you repeat what you think the answer is? Because that's what you should think it is.
Negative square root of 3.
Negative square root of 3. So we locate negative square root of 3, right?
Mm-hmm.
For tangent. First
But then
easy.
you go to, it's negative.
It's negative.
So it's pi.
Okay, so
Negative
it's
pi over 3.
negative pi over 3.
Yeah.
Did I follow perfect logic?
Yes.
Yes.
Yes. That is the incorrect answer.
Seems there are
Because it's
multiple
in
answers.
1 and 2, right?
There are not. What was that?
It's in 1 and 2 instead of 1 and 4.
Cotangent only exists in quadrants 1 and 2. Here's the problem. You have to use tangent to get to cotangent. So we have to be smarter than the solution. This is how we're going to do that. So first of all, we know we're not using quadrant 4. Or 3, I should say. Neither of you use quadrant 3, so that's out of the equation. What was that?
No, I was just
You said the correct answer.
2 pi.
The correct answer will be 2 pi over 3. Let's look at some ways we can get to that. Tan inverse exists in quadrants 1 and 2. Cotangent inverse exists in 1 and 2. So somehow our answer is in a quadrant where cotangent doesn't exist. You have two options here. You can just shoot straight across. That's one way. You can just put your finger on your unit circle and go straight across. Go, okay, I use tangent as just a hint at what the solution is. Cotangent doesn't exist in quadrant 4, so I have to shoot it back up to quadrant 2.
What is that? That's going all the way around, right?
That's adding pi to it, which is going to go back to our chart in just a second. So basically, you just added pi to it, or subtracted pi, get to kind of the same. You do have to get to the 2 pi over 3, though. Okay. Another way you could do this is you can just go, you know what? I understand that tangent exists down there, but I also know that cotangent only exists in quadrants 1 or 2. So you can just go, what if tangent existed in this quadrant? Well, it'd be right here, negative square root of 3, which points to 2 pi over 3. So that's one way. So that's two ways to do this. My first way is just figure out where normal tangent inverse of that would equal and know that you have to shoot it to quadrant 2. My other method I said is, well, pretend that tangent could exist in that quadrant, and that would point to that 2 pi over 3. However you look at it, you have to get to quadrant 2.
Yeah.
Because quadrant 4 does not exist for cotangent inverse.
Even if we change it to tangent, or like we
Yeah,
do
that's
this,
kind of weird.
We're using it as a tool to get to our answer. It doesn't mean it's the exact same answer. Remember we use like reference angles? where we use reference angles to get an idea of where the solution is. For tangent and cotangent, we're just getting an idea where it is, but we have to shoot it to the second quadrant. So that is why we can't necessarily just say these two things are equal. That's why we have up here, if x is less than 0, technically we have to put that plus pi for them to be equal to. But that plus pi is the exact same thing as shooting across or pretending tangent existed in quadrant 2. It's messy. It is probably the hardest part about inverses is tangents of negative angles. Does it at least, I'm not saying that you can do it, does it at least make sense why I did what I did?
Yeah.
Going across and shooting across.
The plus pi is the exact same thing as shooting across. So remember when we ended up down here and I said we can shoot straight across to get to that 2 pi over 3? That's adding pi. It's adding half a unit circle to get back here.
So if it's cotangent, you're gonna always do that.
For cotangent, you always have to put it into quadrant 2.
So you're always gonna add that plus pi.
So only if it's negative.
Oh.
We could see there's overlap in quadrant 1. So if you're in quadrant 1, you don't have to do anything to it. It's only if tangent gets you to quadrant 3, you have to realize that cotangent doesn't exist there, inverse, so you have to shoot it up into this quadrant here, which is adding pi. I don't add pi, I just put my finger on it and go across.
Yeah.
I think it's easier than doing the math behind it.
Yeah.
Or you just find out where tangent in quadrant 2 would equal that negative square root of 2. So you can go, okay, it's cotangent, get rid of this crap, and just go, where would tangent equal negative square root of 3? It would equal here. Cotangent lives there, so I can go 2 pi over 3.
Okay.
We have to, some way or another, get here. Okay, whether that's adding pi, or that's putting your finger on it and shooting across, or you can just say, well, where is tangent equal to negative square root of 3? It equals it at that 2 pi over 3.
So in the equation, do we have to have the plus pi?
No.
We don't have to?
I'm just showing you a whole bunch of different ways to do this. Algebraically, technically, I'm not going to grade you on how you write this. Algebraically, these two things aren't equivalent, so I have to add the pi to have the equal sign. But like I said, what that pi is for your reference is either you're going to put your finger all the way across, or you're going to actually add pi, or you'll just point to 2 pi over 3, okay? Is that okay? Okay. All right, so if I went through this, the whole way we would go, okay, it equals negative square root of 3 at negative pi over 3 plus pi would equal 2 pi over 3. So here's kind of where I put a little picture here where I said what we did is we went down here. We found it was at negative pi over 3. But we shoot straight across because cotangent inverse only exists here to get to our 2 pi over 3. I don't care how you do it or how you write it. Just know that you need to be in quadrant 2 for cotangent inverse. Okay?
Yep.
All right. Now, here's the thing. This is such... If you spend 50% of your time studying this one little fact, you're not spending your time wisely. This only happens for cotangent inverse of negative things. Is this a negative value? No. You don't have to worry about it. This we go straight up. Is cotangent on a unit circle? No. Reciprocal inside. So I'm just going to straight up rewrite this as tan inverse of 1 over square root of 3. Yep. Because we have to do the reciprocal. If you multiply the top and bottom by square root of 3, you should realize that this is tan inverse of square root of 3 over 3. We're in quadrant 1, so we don't have to worry about adding pi or shooting across because they both exist in quadrant 1. We can just simply put that this should be pi over 6, and you're done. So like I said, the hardest part about today's lesson shows up maybe one, maybe twice on the test, maybe. And we'll still get partial credit if we do something like, oh, it's negative pi over 3, because I get your thought process, you didn't shoot it across. So if you're going to spend your whole time studying going, this doesn't make sense to me, and you're spending like hours on this, you're not spending your time wisely. Practice it, obviously. Practice it on tonight's homework. But don't make it your life. All right, let's do some quick recaps. First recap. I'm starting a test. All right, I need to describe something to someone. What I'm going to do, first of all, if I write on the top of my test, I'm just going to put cosine. Bam. Now I know where cosine inverse and sine inverse live. What am I going to add above that cosine? I'm actually going to put the secant. And so next to the sine, I'll put my cosecant. That helps me in two different places. It helps me with inverses, and it also helps me with knowing that cosecant and sine. Now I can just forget about that for a second. Like you don't have to keep going, okay, cosecant sine, cosecant sine. Now it's on your paper. I'm going to put another one of these circles, and I'm going to write cotangent. Kind of like I wrote cosine, I'm going to write cotangent. Now I know where cotangent exists and where tangent exists. So cosine, cotangent, you know what quadrants they're in. Questions? Then that's all I have for you today. The rest of the time is for you to work, try.